Okay, Professor, you're rolling.
Thank you so much. So we are dealing with inhomogeneous structures. What is our topic number? 37. Okay. Past time we actually reviewed this material, and I said that in 18th century, and Leonhard Euler obtained some solutions in 1759. Okay, then 19th century, Engesser. So that is 1899 actually. Then 20th century, we have Duncan, 1937. And all these are in buckling. And in vibrations, no closed form solution. Was recorded since approximately in 1730, Leonhard Euler and Jacob Bernoulli wrote a governing differential equation. And that is d2 dx square ei d2w dx square plus rho a d2w dt square equals 0. So there are closed form solutions only for uniform beams. But not for inhomogeneous beams. Okay? So we will first deal with buckling, and then we will deal with vibrations today. So I will start with homework assignments. What is our homework set number? 20. Okay, so verify Duncan's solution. Means EI of x is denoted as D of x. Then D of x is written as it is written as D sub O d sub o 1 minus 3/7 x over L square. So check that for W equals A, in that it is 7x over L minus 10x over L cubed plus 3x over L fifth power, the differential equation, which is d of x d2w dx squared plus p critical w equals 0 is satisfied, and p critical equals 60 over 7 d sub 0 L square. Okay, this I would like you to verify.
What are the boundary conditions on this?
Yeah, boundary conditions question, very nice question. That is simply supported. You can check that W of x satisfies boundary conditions. Any questions? Now, this is a very beautiful solution. Why it is a very beautiful solution? Because pay attention, for simply supported beam, so which must be simpler, so EI equals d sub 0 and is constant. So we have a solution like this. P critical equals pi square EI over L square. This is inhomogeneous. Here solution, that means that d of x is not constant, and P critical equals 60 over 7 d0 over L square. Now I claim that this is more beautiful. Why do you think that this could be more beautiful? I'm saying that this is more beautiful than this. Let us start with Mr. Van Fan. Why do you think this is more beautiful? If you think that this is more beautiful.
The second one?
Yes, I wrote here, more beautiful than this. Mr. Casey? Yes, there is no, this is a rational expression. So this is irrational expression. So this can be this is an exact solution, but can be numerically evaluated only approximately, because there is pi squared. This can be, so to say, numerically evaluated directly, very easily. So let us obtain some other solutions. Okay. Insight is like this. Sometimes, to solve the problem, it is easier to start with an answer. What does this mean? Say it again. Yeah, going backward. Yes. For example, if I have to solve a quadratic equation, say x squared minus 7x plus 12 equals 0. So then I have to use the formula, is it right? x12 equals 7 plus minus 7 squared minus 4 times 12 divided by 2, etc. But easier to do like this. Easier to pose a different question. Construct quadratic equation whose roots are 3 and 4. In this particular case, that will be 7 plus minus 49 minus 48 divided by 2 equals 7 plus minus 1 divided by 2. So this is 3 and 4. So this is much easier task than to do this solution. We just write, because 3 must zero the equation, as well as 4 must zero the equation. Then, according to the theorem of algebra, this quadratic equation should look like this. So I start with solutions, and I'm constructing x squared minus 7x plus 12 equals 0. So this is much easier to do. This is a direct problem. This is inverse-like problem.
Question.
Yes.
Is this intuitive always?
Let me write it down. What is the question?
Iterative process to a valid solution.
Is this an iterative process? So I will answer by asking question. What do you mean by this?
Solution. Solution to the problem is it always
Okay.
iterative?
So is solution. So to answer this question, if I have an equation x squared minus 7x plus 12 equals 0, then solution is not an iterative process. Because solution is given by quadratic equation, etc. Not an iterative process, there is a formula.
When you, for instance, propose a number, try to come up with a solution. start with an answer.
Okay. Again, I think that there is some misunderstanding. I talked here about two different things. If I have to solve quadratic equations this, then I have rule how to solve it. Fine. Now, but easier to pose a different question. I said construct a quadratic equation whose roots are 3 and 4. For example, if I want to solve the following problem, for example, x in fifth power minus 20x4 plus 17x cubed minus 20x squared plus 19x minus 21 equals 0. So then solution is numerical, not theoretical, so to say, not analytical. Okay, so we have to use some, if you want, iteration process. For example, if this polynomial, I don't know, if it behaves like this, then maybe I will solve like this. If I found that polynomial here is negative and here is positive, then I can use this rule. So I will say that this is a first approximation of the root. But then I'm evaluating function here. If it is negative, then I will use this as a second approximation of the root. Then maybe that will be third approximation of the root, etc. Fourth approximation, etc. If I'm solving problem graphically or numerically like this, then yes, that is an iterative process. But if I want to solve, if I find quintic equation which has roots 1, 2, 3, 4, 5. It's very easy. You just have to multiply and we find an equation that has roots 1, 2, 3, and 4, and 5. So what I meant was the idea is that sometimes inverse problem, say construct equations that has such a solution, is much easier to perform than to solve directly the problem. That was a message. Okay. So we will use this method also for this buckling problem. So we will pose the following problem. Pose the following problem. So find d of x and p critical such that something of a solution is known. By the way, I enjoy very much answering questions, so please ask questions, because if you are not going to ask questions, then maybe someone will be left with misunderstanding of what is happening, etc. So please, 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 by all means, ask questions. Maybe there are some more questions. Mr. Casey? Madame? Mr. Flores? Mr. Dujan? No questions. But please feel free. Mr. Fonfan, maybe you have some another question. Okay. So something of the solution is known. So what is of the solution is known? W of x is known. That is what I'm saying. I would like to postulate, I postulate that I know the buckling mode. Any questions here? Now you should have questions. Miss Silanpa, any question? No. Mr. Vatanachayan? No. Mr. Flores?
No.
Not right now. I think right now you should have questions because I said that I know the buckling mode. The question should be how? How do I know buckling mode? Who told you? Who told you? Okay, what would be an answer? Mr. Fan, imagine you are lecturing and you go, how? How do you know the buckling mode? Who told you? Say it again. Okay, so one, Lagrange told. Lagrange told me will be very bad because Lagrange is not, Lagrange is, he is not alive. So the question is, how do you communicate with someone who is not alive? I mean, did you ask spirits to come, or how did it happen? So student suggestion is maybe possible, but very impractical. I mean, I cannot recommend it in business, Please call Lagrange and ask him. Yes, Mr. Fan.
Okay, and I go into the specific.
No, I want you to answer questions that is posed. No, nothing else, if you don't mind.
Okay, will it be single solution or will it be trigonometric?
So I postulate that I know. I did not specify what it will be. Postulate that I know the buckling mode. So I asked how. Who told you? Who told me? Mr. Duja, who could tell me this? Mr. Casey. Okay, first of all, possibility is facts from heaven. I mean, that could be, theoretically. I cannot tell that there is someone who received such a fax, but theoretical possibility is that there is inspiration, experience. Say it again. No, if I solve problem directly, then it is not a big deal. I mean, I solved problem directly. If I solve problem directly, then it is not. I said find d of x and p critical such that something of the solution is known. No, but we said that exact solutions except these solutions that I told you. Okay? For inhomogeneous bars or columns, except Euler solution, Engesser solution, Duncan solution, there is no other solution known. That we know. That we know. That there is no others. Maybe someone published in some obscure journal that is not available anywhere, and maybe maybe there is something, but we know that there is nothing else, more or less. I mean, as far as we know, that is the best. I mean, there are many reviews written, books written, and not every book, of course, mentions all the solutions, but some of the papers mention at least. Okay? For example, Duncan's paper I have, Duncan's report, written in 1937, so I know that. Yes, I did not see anywhere referenced that exact solution, but it exists. Engesser, that is a paper published in a famous German journal, Journal of Applied Mathematics and Mechanics in 1899. Euler's book is given. I mean, there is something that is called 70 volumes of Euler's works are published, and some of the volumes are available at FAU library. It is called Opera Omnia, Euler's Opera Omnia. Okay, you may want and see each of them contains 500 pages. Okay, I think it is called Opera Omnia, Leonhardi, Euleri, something like that. So this is in Latin. So it's like life's works of Leonhard Euler. Several volumes are available in our library. You may want to. It's very nice experience to go and browse and see. Since 1902, some Swiss society in Basel, where he was born, is publishing all his books. So until now, I mean, more than 100 years have passed. 70 volumes have been published, each of them 500 pages. Okay? So he wrote approximately 1/3 of all mathematics that was written in 18th century. One person contributed 1/3 of it, okay, by volume. Okay, so experience, etc. Let us pay attention, 6. But now we are more clever at this moment. Look, pay attention. We solved some problems by Galerkin's method, approximate method. You remember? So, for simply supported beams, we constructed such a function. Psi, I think, equals psi minus 2 psi square plus psi in fourth power. Is it square or cubed? Cubed. Cubed. For clamped, we psi square minus 2 psi cubed plus psi in fourth power. For clamped simply supported, I think psi equals 2 psi in fourth power minus 5 psi cubed plus 3 psi square, etc. So these functions satisfy boundary conditions. But not differential equation for uniform column. Okay, so we know these functions. You composed them. So now I will ask the question. Question is like this. Is there a column that a non-inhomogeneous column that has as its mode shape the function psi equals psi minus 2 psi cubed plus psi in fourth power? So that is a question. That is for simply supported column. That is a question that I posed approximately 1999, about 10 years ago. Mr. Flores, what are you using there with the book? Does the book have a solution of this problem? Close the book then. Close. Okay, comments? Yes?
How to draw like a column in a conic shape, would it satisfy this?
I don't know. Student is asking if a column is of conic shape. Will it satisfy? I don't know. Paying attention, I don't say I don't know, just most of the scientific questions answer is I don't know. I don't know, you have to check. You have to check the conic shape and substitute and see, and you will see what the answer will be. Any other comments? See, in order to study, person should be naturally be willing to study. That means he must be willing to listen. So you are doing this part very well. But in order to study, one also should be attacking personality. Because studying process is like a war, like a fight. You want to, so to say, take something from someone else. So then you should be more attacking. Okay? There is a story of a teacher who was teaching some child, I think, reading. He said first day that this is A and this is B. Second day he said, this is A and this is B. The child said, how it's possible? Yesterday you said this was A and this is B. Today you say this is A, this is B. Teacher said, I'm very sorry. If you want to learn, that is what I'm telling you. You have to conquer with me. Okay, fine. That is fine. That is fine. But it's beautiful that student asked. I mean, come on, how it is possible that yesterday this was A and this is B, and today this is A. Okay, maybe his science changes every day. You know, maybe the language is dynamic, so to say. On Mondays, that is how it is. So, okay, student took it. But also, one should also ask, why is that? How it is that? Not just to be a sponge that takes everything. So it must be attacking personality also. So, any questions? Any comments? Okay, comments that I had myself. You are very, I think the reason you are not making comments because you are kind people. You raised your hand? No. No, okay. So my comments was that what I'm asking is crazy. Because why in the world there should be a column which has a given mode shape? Okay? That is not, I mean, what are you asking? Come on. Any other comments? Look please what I said. Is there an inhomogeneous column that has its mode shape this? Why there should be such a column? Where did you get this from? There should be no column like this. I mean, come on, I'm giving you a shape and I'm asking you, is there a column? How can I find and why that should be? You understand what I'm saying? Any other comments? Yes?
What's that expression? A priori, you're saying this.
Yeah, I'm a priori saying that is how the column should behave.
You decided to be that way?
Say it again. I'm like talking to the column. I'm talking to the column and telling him, you know what, that is what your displacement should be. How would column respond? Please make comments, say something. It's not important whether what you say is correct, not correct, right, not right. Connected to the subject, not connected to the subject. Far away from truth or close to truth.
But you're saying the column is existing already.
Oh, I said some column. Is there a column? Some column. We don't know. Find the column. Maybe that means that, look please, that column should have some flexural rigidity, maybe change of moment of inertia in some sense, that this will be okay. Okay, let us, my answer was, yes, it does not make sense to pose such a question. That is correct. But let us check. Let us check if there is such a column. Let us search for such a column. If I don't find, I'm not going to tell anyone that I asked such a question. But if I will find, maybe everything is okay. Yes, sir.
I just have a question, an honest question.
Yes.
What's the answer that it did not make sense because it turned out that physically it was not possible?
Say it again.
Was the answer then that it did not make sense because when you went back physically you could not have a column?
No, that is not very, this question, student is asking whether, or, can you repeat?
Again, I mean, because you're saying that then it did not make sense for there to be a column that had these.
No, I did not say it did not make sense. Crazy does not mean that it is nonsensical also, because crazy just means that maybe there is such a possibility. For example, today I think is Wednesday, is it not? Today I think there is lottery of $43 million of, payoff. Now it would be crazy if I will already, I mean, if we, any of us, will be ordering, a house that costs $20 million before we know that we won the lottery, is it not? That is crazy. However, it is not impossible. Maybe you are ordering such a house and you are winning also.
Oh, okay.
So crazy does not mean it is impossible. It is just, unbelievable to pose such a question. It is not impossible question. Naturally, there can be, maybe there is such a column which has this mode shape or any other mode shape. Maybe there is such a column. How to find it, I don't know.
So it did not make sense because we did not.
No, we cannot say now it did not make sense. When you buy books, say, by Agatha Christie, then when you are starting to read, say, a mystery, does not make sense. It is unfair to look in the last page and find who committed the crime. That is not, we don't want to curtail the story and say, like child says, tell me please, did they marry? Because I want to sleep now. This king and or prince and princess, whatever, what has happened? Child wants to know. Okay. So let us look, let us search. At least a priori, such a problem is highly anticipatable that there is no solution. We should be anticipating that such a problem should not have a solution. Why would there be a solution like that? There is no reason in the world that there will be a column that has this function as an exact mode shape. That is what I want to impress you. Why there should be? I wrote just randomly a function. Why there should be a column that has this as a mode shape? That is totally out of ordinary thinking, so to say. Because usually we have differential equation. I have to solve the differential equations. Then I will find mode shape and I will find the buckling load. That is how things are done. Here I'm saying, you know what? I don't want to bother myself with differential equations, solving, etc. I have no time. I want to know if there is such a column that has this mode shape as a buckling load. So let us search. At least maybe there is one, maybe many, maybe none. At least question sounds to be, out of the ordinary naturally, and with a very slim chance at least of positive reply. Okay? Very slim chance of positive reply. You would agree with me with that. So let us start with the differential equation. That is d2 dx squared ei d2w dx squared plus p critical d2w dx squared equals 0. That is an ordinary differential equation, governing differential equation. Okay, I would like to go into non-dimensional coordinates. Now you can write down, Mr. Flores. So this is 0, this is L. So I would like to introduce x over L equals xi. Okay? Then we will have d2w dx square will be then d2w, and x is L times xi. Okay? So that will be L square xi square. So here will be also the same. So there will be then 1 over L squared d2 dxi square ei d2w dxi square, and here is L square, plus p critical d2w L square dxi square equals 0. Okay, this L square and this L square are cancelled. So then this L square comes here. So then EI we can denote as d of xi. So we get the following equation: d2 dxi squared, d of xi, d2w dxi square, plus p critical L square d2w dxi square. This equals 0. And I say that I know w, and that equals psi, and this equals xi square minus 2 xi, plus xi in fourth power. This means that actually my equation is like this: d2 dxi square, d of xi, d2 psi dxi square, plus p critical L square, d2 psi dxi square equals 0. Okay, now the question is, look please, let me write down here. So this psi, as we said, equals xi minus 2 xi cubed plus xi in fourth power. So this is a polynomial then, is it not? This is polynomial of, this is xi in fourth power. When I differentiate once, I will get xi cubed. When I differentiate once, I will get xi square. So that is second order polynomial. Okay? Now this is also second order polynomial, because it's the same. Now question, I want d of xi to also be polynomial. Now question, which order? Which order? Look, this is a second order polynomial. Now here, this also should be a second order polynomial, this whole thing, because this is a second order polynomial. So this must be second order. Must be. So this is already second order. By which order I should multiply second order polynomial such that after differentiating, this will become second order polynomial after differentiating 2 times. I don't hear. Fourth. Let us check. This is second order. If I multiply it by fourth order, will become sixth order. I differentiate 2 times, then I will get fourth order. But it is not second order. It is then fourth order. Second order. D of x must, D of psi must be a second order polynomial. So I will write down d of psi equals b sub 0 plus b1 psi plus b2 psi squared. So then, at least from the point of view of polynomialities, things will be okay. Okay? Then 10. Let us substitute this here. So let us calculate first this. So we start with psi. Psi equals psi minus 2 psi cubed plus psi in fourth power. First derivative equals 1 minus 6 psi squared plus 4 psi cubed. Psi second derivative equals minus 12 psi plus 12 psi squared. So second term will be second term P critical L squared times minus 12 psi plus 12 psi squared. That is a second term. Yes? That is this term. Now first term. So this guy we know, this second order. So d of psi, let us calculate d of psi times d2 psi d psi squared equals b0 plus b